Hey grade 11s, I decided just to make a video going over exercise 2, number 5 and 6 from your hyperbola notes. It would have been the last two exercises of your hyperbola notes, I think, and it's from past papers. So you'll see that the number 5 was from a November 2015 paper, and then when we get to number 6, I think it's, here we go, from the May-June 2018 paper. So you have got the answers already, and hopefully you've marked your work, but maybe you don't understand the answer. So what I'm basically going to do is I'm going to go through the question, and then I'm just going to work through the answer that you have. Okay, explaining it as I go. So listen carefully. Hopefully my explanations will assist you in understanding. So firstly, when it comes to number 5, it says the function defined as y is equal to a over x plus p plus q has the following properties. So obviously we can see that we are dealing with a hyperbola. The giveaway is that there's an x in a fraction, so definitely a hyperbola. The domain or the x values is x is an element of real, but x cannot equal -2. So if x cannot equal -2, that would mean that -2 is an asymptote of this hyperbola. It's never going to cross -2. So you'll see in the solution here, the first bullet point tells you that. It says the domain is x is an element of real, but x cannot equal -2, tells us that x equals -2 is an asymptote. Okay, so if I'm just looking at my diagram that's going to slowly build here, there is my vertical asymptote at -2. In other words, the x value of that point of intersection where the two asymptotes will meet is -2 for x. Right. We carry on reading the question. It tells us that y is equal to x plus 6 is an axis of symmetry. Right? You remember that now. The positive 1 in front of that x tells you it's a positive gradient of 1. So looking at my solution here, if you follow my cursor, there, that positive gradient, that axis of symmetry, is the line y is equal to x plus 6. Right. So it's important for you to notice that that line goes through the point of intersection of the two asymptotes. So where these two dotted lines meet, the asymptotes, is where this axis of symmetry is going to go through. So y is equal to x plus 6 is an axis of symmetry, right? That's what I'm going to reveal in the sentence here, right? It intersects the asymptotes at their point of intersection, right? So this point here of intersection, we already know is -2 and something. That something, we can substitute x of -2 into the straight line's equation. Why? Because the straight line is going to go through that point where x is -2. So instead of y is equal to x plus 6, we're going to say y is equal to -2 plus 6. So y is 4. Now working y to be 4, that means that that point there is -2 and 4. It also means that the horizontal asymptote is where y is equal to 4. So we've got both asymptotes now. Then, depending on what value a is, we're going to either put a and the arcs of our hyperbola in quadrant 1 and 3 or 2 and 4. How do we know where to put the arcs? Let's go back to the question. It says also that the function is increasing for all values of x except when x is -2. How come x -2? X will never equal -2, so it's doing nothing there. If the function is increasing, going back to our answer, reading left to right, it always means that the arcs are going up, right? Always increasing in value. That's why we know to be in the quadrant 2 and quadrant 4. Right, these are just rough graphs. We're not sure of the exact intercepts here of this arc, but we have got a basic sketch graph of this hyperbola. Okay, so hopefully exercise 5 makes sense. It was a bit tricky, but hopefully that assists you. Right, moving to number 6. Number 6 from a past June paper says the following. The graphs of fx is equal to 2 over x plus 1 plus 4, right? So this is a hyperbola, which we know everything about. Do you agree? What does the plus 1 mean? It shifted 1 to the left. What does the plus 4 mean? It shifted 4 units up, right? So we know everything about the f graph. And the parabola g are drawn, right? We don't know g. They didn't tell us the equation of g. But there is f over there, and there is our sad parabola. Sad, so obviously we know that the a value would have been negative, but we'll get there. It says also that C is the turning point of G. Okay, so there's C on our picture, is the turning point of our parabola, lies on the horizontal asymptote of F. Right? So if we know what the horizontal asymptote of the hyperbola is, we should know what our Y value is of the C. Right? Does that make sense? The graph of G, our parabola, passes through the origin. There it is there. So there's a point that we might need to sub in later of 0 and 0. B, which is K and 14 over 3, is a point on F. Right? There it is, B, K and 14 over 3. It's on the hyperbola such that BC is parallel to the y-axis. Right? If BC is parallel to the y-axis, it would mean that the x value of B, which is K at this moment, the x value of B and the x value of C would be the same. Happy. So we've read through the question carefully and we've got a feeling for what it's all about. Now we go to the question. Write down the domain of F. The domain of F refers to the x values of F, and F is our hyperbola, and F will touch and affect all the x values, except this vertical asymptote here. So what is the value of this vertical asymptote? Because it's shifted 1 to the left, right, because of that x plus 1 over there, it means that this vertical line over here is the line x equals negative 1. So if we go look at our answer here, the domain will therefore be x is an elemental real when we eventually get there. Here we go. X is an elemental real, but x cannot equal negative 1. That dotted line, that vertical dotted line there, the hyperbola will never feature at that dotted line. It's an asymptote. So all the other x values work. 6.2 asks us, determine the x-intercept of f, right? F was our hyperbola. To find that x-intercept over there, how do we find an x-intercept? To find the x-intercept, make y equal to 0. So, going back to our answer here, 0 is equal to 2 over x plus 1 plus 4, right? So we just got to solve for that x. We subtract the 4, so negative 4 is equal to 2 over x plus 1. I then multiply this x plus 1 out, so the negative 4 must get times by x plus 1. So negative 4x minus 4 equals, the 2 is now left. So what do? We take the negative 4 and we add it, so 2 plus 4 is 6, so negative 4x is equal to 6, making x, what? 6 over negative 4, or negative 1 comma 5. Right, so we've worked out the value of x to be negative 1 comma 5 in this question. I don't know why I've highlighted it in green. Let's try, and let's just leave it in green. Okay, so x's value is negative 1 comma 5. There, that x-intercept of our hyperbola is negative 1 comma 5. Okay, by making y 0. Moving to 6.3, calculate the value of k. In other words, there, that k value there, what is its value, right? It is the x coordinate of b, right? So it's on the hyperbola. So if we know at this position y is 14 over 3, we can sub 14 over 3 into our hyperbola and find out what x is, right? And x's value is the k value which we've got to find here. So 6.3, let's go see our answer. Here we go. I've made the y 14 over 3. So 14 over 3 is equal to 2 over k plus 1. Why? Because k has replaced the x value, plus 4. Right, so we're now solving for this k value. So we subtract the 4 on the left side. There it is there. Subtract 4. So 14 over 3 minus 4 gives you 2 over 3 is equal to 2 over k plus 1. Now we could cross multiply, I guess, right? So we would have had, I guess we can just look at properties of fractions here. If the tops are both 2's, right, the tops are equal, so the bottoms would need to be equal. That's how we've simply jumped to k plus 1 equals 3. We could have got there a bit slower, but if the tops are the same, the bottoms would have to be the same as well. So k plus 1 equals 3, so k's value ends up being 2. All good? Makes sense? So k's value is 2. If I go up to my picture, there, k's value is 2. Now, we're predicting what the next question will be. If k here is 2, what will the x value be for c? It will also be 2, right? So let's go see if that is indeed the next question, bearing in mind that k is 2. Here we go. Write down the coordinates of C. So if we know, I'll say it again, if we know that this k value is 2, it means that C's x value will be 2, right? So if C's x value is 2, how are we going to get the y value? Remember earlier on we read that this point C lies on the horizontal asymptote of the hyperbola. What was this flat line now? How much is it, or what's the value of that flat line? That value would have referred to this plus 4, right? It's the horizontal asymptote, the shift up. So C's value will therefore be 2 and 4, right? 2 because it shares it with the letter K here, and 4 because it's on the horizontal asymptote of the hyperbola. Let's just confirm to make sure we are correct here. There we go. C's value is 2 and 4. Right. Number 6.5 asks you to determine the equation of G, our parabola, in the form y is equal to a brackets x plus p all squared plus q. Right. So how will we get it into this format? If we were given the parabola's equation as y is equal to ax squared plus bx plus c in that format, we could have used completing the square to get it into this format. But we do not have the original parabola and its equation. So we are going to have to use the fact that we know C's value is 2 and 4. Remember, the P and the Q in this new formula tells you the turning point. So we have shifted how? Let's go have a look. The turning point of C has moved to the right of the origin and up. So that means we're going to have, let's go look, x minus 2 in brackets, shifted to the right by 2, and plus 4 shifted up by 4. Okay, so that's where C's coordinate went to. The P value, -2, and the Q value, 4. We still do not know the value of A. We know that A is going to be negative because it's a sad parabola we got here, but we need to work it out. So we substitute in another point. The other point we have on the parabola is the point 0 and 0, the origin. So 0 is equal to A, brackets 0 minus 2 all squared plus 4. So 4A is equal to -4, making A -1. If A is -1, does that confirm the shape of the parabola to you? Yes, it's a sad parabola, so our answer makes sense. We put the answer back into what we had so far, making y is equal to -1, brackets x minus 2 all squared plus 4. Okay, good little question. 6.6 and 6.7. Now step it up. Are you ready? 6.6 says, for which value or values of x will f of x divided by g of x be smaller or equal to 0? Right. So f of x, let's just make sure we're ready for this. F of x is our hyperbola and g of x is our parabola. So the question is saying, when will our hyperbola divided by our parabola give us an answer that is 0 or negative? Right. Now, how do we get a negative from a fraction? Either by saying a positive divided by a negative or a negative divided by a positive. So if we go look at our picture, at our Cartesian plane, you will need to have one function above the x-axis being positive and the other function below the x-axis being negative. So the best way to look at these kind of questions is to read from left to right. So if you can see my cursor here, I'm going to go from left to right and we are going to spot where the hyperbola is and where the parabola is. So let's start. Watch my cursor. We first get over here. The F graph, our hyperbola, is positive, 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 all for this area here. While it is positive, where is the parabola in this area? The parabola would be down at the bottom. The parabola is negative in this area. So this coordinate here of the x-intercept of the parabola was -1,5. Can you remember? So everything smaller than -1,5, if the hyperbola would have been positive and the parabola would have been negative. What is a positive divided by a negative? It is negative. So we want that area. Let's go look at our answer. Here it is. X is smaller or equal to -1,5. to the left of negative 1, 5. I'll say it again. To the left of where my cursor is, our f will be positive, our parabola will be negative. So we pick that as an answer. Just after negative 1, 5, in this little area here, what's happening? They are both negative. Do you see that my hyperbola is below the x-axis? And my parabola would also have been below the x-axis. So we don't want that area, because negative divided by negative is a positive. We don't want that area. We want negatives from our fraction. Afterwards, in this little area here where my cursor is, what is this space here? It's between 0 for x and negative 1. So what's happening in this little area here? Your hyperbola up top here is positive. It's above the x-axis, while my parabola is below the x-axis. So a positive divided by negative is negative. But will we choose negative 1? Can we take negative 1 as one of the values of x? No. How come? Because the hyperbola does not exist here. So we can't have including negative 1. Can we take 0? No. Because if we divide by 0, because g of x is 0 at 0, right? If we divide by 0, it's going to freak out. So we can't take negative 1. We can't take 0. But we can take everything in between there. So my second part of the solution, or x lies between negative 1 and 0, but no little lines there, no equal to's. Okay, back to our picture. Between this area of x of 0 and x of, I think this is 4, right? This is the other, why would this be 4, by the way? Why would that x-intercept be 4? Well, if c is 2 and 14 over 3, or 2 and 4, right? From 0 to 2 is a move of 2. So then c to the other x-intercept will also be a move of 2. So then this x-intercept will be 4. Okay, symmetry. So from 0 to 4, both functions are positive. Do you see? Both the f and g graphs are above the x-axis, are positive. So we don't want that area, because a positive divided by a positive is a positive. We're not going to generate a negative. But after 4, right? After 4, what's happening? Our parabola is now negative below the x-axis, but our hyperbola is still positive above the x-axis. So we are happy for positions after 4. So there we go. X is greater than 4. Why can x not be equal to 4? Let's go have another look. Why can x not be equal to 4? Because at 4, our parabola was 0. And if we have divide by 0, it's going to cause us issues. So we do not pick 4. Right. So a decent question there would have got you thinking. Please rewind and listen to my explanation again if you're not too sure. Right. Number 6.7. Also a nice toughie. Let's read carefully. Use the graphs of f and g. Okay. So we're going to use what we've been given to determine the number of real roots. So answers or x values of. Right. So now let's be careful here. We have got a hyperbola here, but this hyperbola differs to the hyperbola we were given in our question over here, right? Do you see it's quite a bit different? We are also given a parabola over there, but it's also different to the parabola we've worked out. So let's just look at the answer for this one to talk you through it. Firstly, our original hyperbola, which I've highlighted here in yellow, has moved 1 unit to the left and 9 units down in order to land up with this hyperbola y is equal to 2 over x minus 5, right? How did I get this 1 left, 9 down? Well, x plus 1 indicates a shift to the left by what? It indicates a shift to the left by 1. Now, what is this? So this should be to the right, hey? Let me just double check here. Wait. It's shifted to the left by 1. So I think this could be an area. It's moved 1 unit to the left. This should be right and 9 units down. How come 9 units down? Because plus 4 ended up being a minus 5. So 9 units down. Then we go to the second one, the parabola. y is equal to -1 x minus 2 squared plus 4, so that's the parabola as we know it, has moved 1 unit to the left and 9 units down to give us x minus 3 all squared minus 5. Okay, how do we get that? The plus 4 at the end of our current parabola is now minus 5, so 9 units down. X minus 2 indicates 2 to the right, is now x minus 3. So we've moved another unit to the right. Okay, so bear in mind here, I'm just going to maybe make this left into a green. That should be right, gentlemen. Okay, we have moved 1 unit right and 9 down. Okay, so if you go back and look at your two functions as they stand, we're going to be moving them both 1 unit to the right and 9 units down. Do you agree that this parabola would be below the x-axis, right? There would be no x-intercepts, in other words. The hyperbola, 1 unit right and down 9. Do you agree then? Okay, and you're just going to have to visualize this. Do you agree that if we've moved them both the same places, 1 right and 9 down, the only place where these two graphs will cut will be over here where my cursor is. These two arrows would eventually chop each other. Hey? The parabola would eventually come across and cut the hyperbola once down here in the third quadrant. Okay, there would be no intercept here in the top somewhere. Okay, so the answer, to wrap this discussion up, the answer here is simply to say, as the movement is the same, so the number of intersections will be the same, right, as that of the given function. There is only one point of intersection, and it will be in the third quadrant. Okay, just bear in mind that that left should have been a right. So, yeah, does that make, hopefully that makes sense. It's a bit of a confusing end to the video. But definitely a more higher order question, getting you to think a bit. Okay, please work through this carefully, follow my explanations, shout if you have any questions. But yeah, keep working hard, gents.